In this chapter, we introduce the concept of repetition or looping, and we're going to do that by demonstrating two major types of loops in C#, the while loop and the for loop. We're going to begin with the while loop, but we're going to start with what I'd like to call a motivating example. In other words, why do we need looping in our programs? So let's look at a very simple example. Let's say we want to compute the balance of a savings account that earns simple 2% interest for 5 years. To do that, we need a variable for the balance and a variable for the rate. We'll set the balance equal to 1,000. We'll set the rate to 1.02, same thing as 2%. We're just not going to add back, we're going to multiply by 1.02. Then to compute the balance for 5 years, we simply multiply that times the rate 5 times. So there's the first year, there's the second year, there's the third year, there's the fourth year, and there's the fifth year. When we're finished, we can display the result. The balance after 5 years is plus the balance. Then we run the program, and we see that it's $1,104.08, give or take some fractional cents. Clearly we need to optimize the code that I've highlighted here because we're just typing the same statement over and over again. That's where a loop comes in. So before we discuss the while loop formally, let me just show you how we can modify this program to work with a while loop. So I'll comment out those lines of code. We need to add a new variable, years, that keeps track of how many years the loop's going to run. And then we're going to say while years is less than or equal to 5, balance times equal rate. And then we have to modify years so that it will eventually become greater than 5 so that the loop will stop. Again, we're going to talk about the formalities of while loops in the next lesson. So now we can run the program, and there you see we get the same result. The balance after 5 years is $1,104.08. And yet, rather than type 5 lines of code, we knocked it down to just a few, including some extra things we didn't use in the first example, or in the balance times equals rate lines. However, what if we were computing this for 25 years or 50 years? Then clearly writing it as a loop is much better than writing all those statements over and over again. Nobody would even consider doing that. But that's what looping does. It gives you the opportunity to repeat the execution of one or more lines of code as many times as you need for the problem that you're trying to solve. So that should motivate you for why you need to learn about loops. So let's move on to the next lesson where I introduce while loops more formally. Now that I've demonstrated why we need looping, we can begin looking in more detail at the while loop. Let's start by looking at the syntax template for the loop. Begin with the keyword while, followed by a relational expression. This expression will return a true or false value, of course. After the relational expression is a statement block, and in that statement block will be the statements that you want to repeat over and over again in the loop. There can be as many or as few as you need. I'd say most loops have at least 2, but you could actually get away with 0 in the right situation, although we probably won't see that in this course. And that's all the formal pieces of a while loop: the keyword while, the relational expression, and the statement block. But there's actually quite a bit more to while loops than just that. So let's take a look at the balance example from the last lesson again. So we started off with 2 variables, balance and rate. We assign values to both of those, so we'll do that again. Then we created a variable, years, and we set it equal to 1. The first line of our while loop, while years less than or equal to 5. The variable years is something I like to call the loop control variable, because it controls how long the loop is going to run. So here we're saying that while the value of years is less than or equal to 5, then multiply the balance times the rate, and then increment years by 1 again. Now we have all the pieces. If we had to break down the steps that we have to take to write a while loop, given that we're going to use a loop control variable like years, then the first step would be to initialize the loop control variable. Then the second step is to write the actual keyword while followed by the relational expression, which will include the loop control variable. Then, inside the statement block, we have the statement that performs our major work, which is multiplying the balance by the rate and putting that back into the balance. And then finally, the last step would be to modify the loop control variable so that the relational expression will eventually become false. By incrementing years each time through the loop, we're ensuring that years will eventually become 6, which will make this relational expression false and will break out of the loop. Without the increment of years plus years, then the loop would run forever, executing this same statement over and over again. Well, we don't want to do that. We only want it to execute 5 times. So we increment years by 1 so that it eventually will get to 6. Let me add a console write line statement here. And here we go. So now we can run it. And we see the result. Something we might also do while we're testing our loop and seeing if it works correctly would be to add another console write line statement right here with the balance and the years, just so we can see how it's progressing. Now let's run it again. We see the balance after 1 year, we see the balance after 2 years, after 3 years, after 4 years, after 5 years. You don't necessarily need that statement, and it's certainly not what the problem called for. The problem called for determining what the balance is after 5 years. But by adding these statements, we can follow the progression of the program until it's finished. Once we're finished, we don't need this statement anymore, so we take it out, put the program back to the state it was before, and then just run it again. Not all loops require a loop control variable. Some loops use something called a flag, and what's called a flag or sentinel controlled loop, where we're looking for some particular condition to occur, such as end of the file or when you're out of user input, something like that. But in many programs, you do need a loop control variable. So that's why I introduced this type of loop first. So those are the details of writing a while loop. What I want to do now is move to the next lesson where we're going to look at a particular type of loop that uses a loop control variable. It's called a count controlled loop. In this lesson, we're going to talk about one type of while loop, the count controlled loop. And we actually saw an example of that in the previous lessons with the balance calculating program. But let's look at a couple other examples. A very simple example would be a program that sums a range of numbers. Let's say the first 10 integers. So the way we do that is the first thing we do is we create the loop control variable, which is number, and we'll set it equal to 1. Then we'll create another variable sum and initialize it to 0 to store the sum as we work through the numbers. The next step would be to write the while loop itself. So we're going to say while number is less than or equal to 10 because we want to sum the first 10 integers, 1 through 10. So while number is less than or equal to 10, then in the loop we add the current value of number to the sum, and then we increment number by 1. Let's write out the sum right here. And the sum is 55. So we're saying this is a count control loop because we're controlling the number of times the loop is executed. The variable that does that is number, and it is again our loop control variable, so we'll add a comment here. So the limiting factor is number less than or equal to 10. And the other key element besides adding to the sum would be the increment statement right here. Without that, again, the loop will be an infinite loop and never stop. But by incrementing number by 1, number eventually becomes 11, and 11 is not less than or equal to 10, so the loop stops. Another example of a count controlled loop would be one where instead of saying what will our balance be after a certain number of years, we can also say how many years would it take for a savings account to be at a certain balance based on an interest rate. So let's look at that problem. I'll comment out these lines to leave them here. So we want to know how long it's going to take a savings account balance to reach a certain amount. So to do that, again, we'll need a balance and a rate variable. We'll also need a years variable, which we're going to set to 0. We'll assign our balance. We'll assign our interest rate. We'll do 2% again. Let me scroll up a little bit here. And then we're going to say while balance is less than 5,000, and that will be our control. We want to see how long it's going to take our balance to get to 5,000. Then we're going to increment balance by multiplying it by the interest rate, and then increment years by 1. Then outside the loop, we'll write it will take years to reach, like so. So now this time the loop control variable is being modified in the statement that does most of our work, and that is the controlling factor. It's actually the number of years that we're interested in more so than the balance, which kind of flips our program from the last lesson around, because before we were interested more in the balance, but this time we're more interested in the years. So let's run that program and see what we get. We left out the word years out of our sentence here, our output, but you get the main idea. It will take 82 years to reach 5,000, and we can fix that by putting years in right here. Got to stop the program. So we'll run it again, and there it says it will take 82 years to reach $5,000 at 2%. And notice we're not adding any into the balance either. We're just taking the balance and then just adding the interest every year. We're not actually adding any principal to that. So those are two examples of what are called count-controlled loops. As I said earlier in the previous lesson, that's one example of a loop type. Another example is something called a sentinel or event-controlled loop, and we're going to look at that in the next lesson. The second type of loop we want to look at is called an event-controlled loop, or sometimes also called a sentinel-controlled loop. In this loop, we're looking for a specific value or event to happen, such as entering a certain number or a certain word. We're going to work with numbers in both of the examples in this lesson, so we're going to be looking for a particular number entered to stop our loop. So we'll start out with the program to average a series of test scores. So to do that, we need a variable for the average, which we'll initialize to 0.0. We need two integer variables, a total variable and a grade variable. We'll go ahead and initialize total to 0 also. Grade will be entered by the user. The first thing we're going to do is prompt the user to enter a grade. Oh, I left out one variable. I'll add it in just a second. We also need a count variable, so we'll know how many grades to average when we compute the average. So we prompt the user to enter a grade, then we store that grade by converting it to integer after we've read it from the console, just like we always do. Now here's where we write the event or the sentinel. We say while grade not equal to -1, because a grade can be 0 through 100, maybe more than 100 for extra credit, but we'll say 0 through 100, but can't be -1. We're certainly not cruel enough to give negative grades for tests. So while the value of grade is not equal to -1, add that grade to the total, increment the count by 1. Let's do a prefix increment. And while we're at it, let's also initialize count to 0, like so. There we go. And then after we've incremented count, then we need to prompt the user to enter a grade again, because we need to get the prompt and the input inside the loop. So we're going to Control-C, Control-V to copy in there. Notice that the second line always gets scooted over, so we'll move it back. And that should close out the loop. So the user is going to enter grades until they enter a -1, and then the loop will stop at that point. So once that happens, then we're going to compute the average by dividing the total by the count, and then we can write out the average to the user. And let's do one more thing. In our prompt, let's write -1 to quit, so the user will know exactly how to quit out of the program, or at least quit out of the input loop. There we go. So there's the program, and again, the event that we're looking for is a grade of -1. At that point, the loop will stop. Otherwise, we'll continue to enter grades and add them to the total. So let's run this program and see how it looks. Some even number grades, we'll do 100, and then 90, and then 80, and then 70, and then 60. And then we'll type in -1, and the average is 80. So the event of entering -1, or sometimes that's also called a sentinel value, -1 being the sentinel that we're looking for to make the loop stop. So let's look at one more example of an event-controlled loop with numbers. Let's comment out our code from before, and then we'll work right below it here. Let's have the user enter a series of numbers and then determine which one is the largest while the user is entering the list of numbers. So what we're going to do is we're going to create a variable called largest and set it to 0. Then we'll also create a variable number. And then we'll say console write, enter a number 0 to quit, and then number equals convert to int 32, console read line, like so. And then while number is not equal to 0, then we loop. Then we say if number is greater than largest, largest equals number. And of course on the first entry, if it's greater than 0, and it will be since 0 is only to quit, then the number entered will be the largest number. Then all we have to do next is once again prompt the user. We'll just copy and paste that back in here at the bottom. Close out the loop and then write out the answer. There we go. We have a console read key in there already. So let's run the program. So we'll enter 5, then 2, then 10, then 7, and then 12, and then 0, and the largest number is 12. So of the numbers that we entered, 12 was the largest. So these are two examples of what are called event-controlled or sentinel-controlled loops, where the event would be the user enters the value that leads us to drop out of the loop, or the loop looks for the sentinel value, in this case 0, in the other case it was -1, that causes the loop to stop. So that wraps up our discussion of while loops for this chapter. We'll look at them again in the exercises. But now we're going to move to a second type of loop, and that's called the for loop. And we'll see that in the next lesson. The second type of loop we're going to discuss in this chapter is the for loop. For loops are different than while loops in that for loops are always set up to run a specific number of times, unlike a while loop, which might be set up as an event-controlled loop and could run almost forever if the event that you're looking for never occurs. With a for loop, you always specify how many times the loop's going to run. So let's first look at the syntax of the for loop before we look at our first example. We'll do that up here in comments. We start off with the keyword for, and then open parenthesis. And then the next thing we do is we initialize a loop control variable. And I'll explain how that works in a moment. Then we perform a relational test on the loop control variable. And then the next thing we do is modify the loop control variable in some way. This is very similar to what you do with the while loop, but we're doing it all within these parentheses in the heading or in the first line of the for loop. Then once you've finished that, then you just have a statement block, just like you would in any other loop, and then close out the loop. So there's a lot of work being done inside these parentheses, as opposed to in a while loop where we do a lot of the testing and things, the modifications inside the body. All right, so let's look at an example of a for loop. Let's start off with the simple one. Let's sum the first 10 integers. So we need a variable for the sum, and that's really all we need. Here we can say for int I equal 1. I is our loop control variable, and we're initializing it to the value 1. Our test is while I is less than or equal to 10, and then our modification is we're going to increment I by 1 each time. The body of the loop simply consists of sum is equal to sum plus I, or sum plus equal I, followed by closing the loop, and then we can write out the sum, like so. Let me scroll this down a little bit so you can see the parts. So again, I is the loop control variable. We initialize it to 1 since we're going to sum the integers 1 through 10. Our relational test is I less than or equal to 10, so the loop is going to run while I has a value less than or equal to 10. And then to make sure we get to the point where the loop will stop, we increment I by 1 each time. In the statement body, all we do is add I to sum, and then at the end we write out the value. So let's run that program, and the sum is 55. Quite simple. For loops are preferable to while loops when you know exactly how many times the loop is going to run. So while I could write this exact program as a while loop, it makes a lot more sense to write it as a for loop. So that finishes up our introduction to the for loop. In the next lesson, we're going to look at some more advanced examples of using the for loop and some modifications we can make to the statement itself. In this lesson, I want to look at two different for loop examples where we stray from the standard of incrementing by 1 and moving up through some count. In the first example, we're going to modify or change the modification statement so that we don't just increment by 1. And in the second example, we're going to work backwards and count down from a higher number to a lower number. So in this first example, what we're going to do is we're going to display the odd numbers from 1 through 99. So to do that, all we need is a for loop with the loop control variable starting at 1 while it's less than 101. Could have said 100 there, but I'll say 101 and say that we're printing 1 through 100 odd. And then right here is the difference. Rather than a increment operator, we need to use a composite assignment operator and write I plus equal 2. So that I will be 1, then 3, then 5, then 7, then 9, and so on. In the body, all we need is just a console write, and we'll have I with a space so that we can easily read the output. And let's run the program. And you see we get 1, 3, 5, 7, 9, 11, ... 95, 97, 99. Also notice that I did not put the for loop body in curly braces. That's because I just had one statement, and one statement doesn't require curly braces. Had I had 2 or more statements, then I would have had to put curly braces around those for them to all be inside the for loop, but for one statement you can leave the curly braces off. So this example shows what to do if you need to increment by more than 1. Let's comment that out and look at our second example. In this example, we want to work backwards or count down from a high number to a low number. The example I'm going to demonstrate is reversing the contents of a string. So first of all, we need a string. We'll create a variable word and assign it the value hello. Then we need to understand a couple of properties of strings. One property is the length of a string. The length of a string is the number of characters in a string, so hello has 5 characters, so the length is 5. The other thing we need to know is that each character in a string has a position, and the positions are numbered starting at 0, so that the H in hello is at position 0, the E is at position 1, and so on, so that the O is at position 4. So the length is 5, but the position of the last character is 4, and that's going to play a role here in just a second. So to start at the last position, we need to initialize our loop control variable to that. So we're going to write word.length minus 1. The length is 5, but we want to start at position 4, so length minus 1 will get us there. Then we want to loop while I is greater than -1 because the last position is 0. So we want I to be 0, but we don't want I to be -1. Once that happens, then we're actually to the left of the string, we're out of the string, and that's an error. And then we want to decrement by 1 because we want to go from 4 to 3 to 2 to 1 to 0. So that's our loop. The body just needs to be a console write statement. But we can't just write anything. We have to use another function, substring, to pull out one character at a time. So substring takes 2 arguments, a starting index, which is going to be I, our position in the string, or our current position in the string. And then it takes the length of the number of characters you want to pull out in the substring. In this case, we just want 1. We want the current character only, so that we get the O, then the L, then the other L, then the E, then the H. That's all we need to do. So we close it off. Again, we don't need curly braces because it's one statement only. And we run the program, and we see hello backwards is OLLEH. To demonstrate the versatility of our little program, we'll change the length of the string to something a bit longer. This time hello world. Run it again, and it still works just fine. DLROW space OLLEH. So these 2 examples demonstrate some other things you can do with a for loop rather than just work from 1 to 2 to 3 to 4, or however you're going to count upwards. You can count upwards by increments more than 1, or you can work backwards using a decrement. For the next lesson, we're going to talk about some other modifications you can make to the for loop, as in where you place the initialization statement and where you place the modification statement. In this lesson, we're going to look at some ways you can write for loops that differ from the standard way you write for loops. I'm demonstrating these to you just to give you a complete overview of for loops. I'm not advocating that you should use the methods I'm going to show you today. So let's get started by going back to our original program that used a for loop to sum the first 10 integers. The first thing we're going to do is create a sum variable, assign it the value 0. Then we're going to say for int I equal 1, I less than 11, or I less than equal to 10, either one would work, plus plus I, sum plus equal I, and then console right line, the sum is, let's run it to make sure it works correctly. The sum is 55, that's correct. The first modification you can make is you can put the loop control initialization statement outside of the main loop. So let's move it and put it right here. Now, notice when I do that, it automatically flags an error. That's because I now have a missing statement in my for loop, so I need to add a null statement for the initialization statement. And I do that by just typing a semicolon by itself. So now we have for null I less than 11 plus plus I. Run the program, and it still works correctly. The difference is now I becomes part of my main program. Before, let me modify it back, I was only available within the for loop itself, but by initializing I outside of the loop, I now have I available to the rest of the program. That may not seem like a big deal, but it does create some software engineering issues that you probably don't want to deal with, especially in a larger program. So it's usually a good idea not to write your for loops this way, but it can be done. The second modification we can make is that we can place the increment statement also outside of the loop, like so. Now, when I do this, I have to turn this into a block. You see how the editor tries to put plus plus I outside of the loop. I need it back in there, so to do that, I have to turn this into a block with the curly braces. Let's run the program again, and you'll see that it still works correctly. So these are two modifications you can make to for loops, but they're not recommended. One of the things I'm very, very big on is that you write your programs as much for other people to read as for computers to execute. And when you write your for loop like this, you're causing the reader to have to do extra work to try to figure out exactly what it is you're trying to accomplish. Whereas if you write it in the standard form, you're writing the for loop in a way anybody familiar with C# will know exactly what you're trying to do. So you really shouldn't perform any of the modifications I showed you in this lesson, but they are available to you. And in the interest of full disclosure, I thought I'd show you how to make those changes. But again, one more time, I don't recommend doing them. So having said that, we're ready to move to the next lesson, and we're going to look at two statements that can be used with both while loops and for loops to modify the actual control of the loops themselves. And those statements are called break and continue, and we'll see them in the next lesson. There are two statements you can use in C# to modify the flow of control in a while loop, or a for loop for that matter, although we're going to look at while loops in these examples. These statements are the break and the continue statements. Let's start off by looking at the break statement. The break statement will break completely out of a loop when the statement is executed. Let's look at a very arbitrary example. And we're going to create a variable number, and then we're going to say while number is less than 100, console write line number, if number equals 50, break. Well, we'll do it postfix. It really doesn't matter if we do prefix or postfix for this particular problem. Okay, so you see we say if number equals 50, break. So what's going to happen is if number obtains the value 50, then the program is going to break and we'll go out of the loop completely and stop the program, because that'll be the last statement. Let's see if it works. Yes, you see it stopped at 50. So the break statement can be used to stop a loop under a certain condition. It's really hard at this point in this course to show you the types of conditions where break is necessary. When we get to working with data structures such as lists and arrays, and we do searches on those lists and arrays, then we can use break when we want to stop after we found an item. But for now, we're going to have to make do with this artificial example showing how break works to stop loops. The next example is a little bit more useful. It's the continue statement. Continue will cause a loop to move to the top of the loop statements, the statement block, for the next iteration. So what I'm going to do is create an example that demonstrates how continue works. We're going to create a program that allows the user to enter numbers and then perform division on those two numbers. So we're going to have two variables, numerator and denominator, and we're going to have a char variable more that contains the user's choice for whether or not to continue with another example. So we're going to say while more is equal to y. Then we'll prompt the user to enter the numerator. The console read line right here. Then we'll prompt the user to enter the denominator. Now here's where continue will come in. If the denominator is equal to 0, then we have a problem because we cannot legally divide by 0. C# does not allow that. So what we want to do is we want to alert the user, can't divide by 0, and we want to continue. And what that means is that we want to go back to the top of the loop and prompt the user to enter another numerator and denominator. Otherwise, else, we want to go ahead and display the result. So we're going to display numerator divided by denominator. Then we'll ask the user if they want to work another problem. Yes, no. And then get that answer and store it in more. Right here, we left off the parentheses, so let's get that in there. And we haven't closed off the while loop, so let's do that right here. And then we'll add a console write line finished just to let the user know when the program is actually finished. Alright, so here's the main program. So the continue, when the user enters a 0 for denominator, the continue should be evaluated and should send us back to the top. So let's run the program and see what happens. So we'll do a legitimate problem first. 12 divided by 2 is 6. So it prompts us for another problem. We'll say yes. 11.2 divided by 2.3. Then we'll say yes. And then we're going to say 23 and 0. We get the error message, can't divide by 0, and it takes us back to the top, asks us to do another problem. So we enter 23 and 2 to get 11.5. And then we'll answer no there. And then we get the finish. So the continue statement allows us to continue with the program just back at the beginning of the loop rather than breaking us out completely like the break statement does. Both of these statements have some utility and are useful. However, you need to be careful and don't come to rely heavily on either one of them, especially the break. But continue is somewhat useful in situations like this when an error condition occurs, but you want to continue, you just want to start over. That wraps up the main lesson material for this chapter. And now we're ready to move to the exercises. And in the first exercise, we're going to use a while loop to rewrite our question and answer program from the previous chapter. For this first exercise, we're going to rewrite the question and answer program from the last chapter where we asked the user what was the name of the computer that played on Jeopardy. So let's get started. First thing we're going to do is create a string variable that stores the answer to the question, and that answer is Watson. Then we're going to create a string variable to store the user's response after we ask them the question. Then because we're only giving them 3 tries, we need a variable to store the number of tries. So we'll have that variable next. Now we begin the loop. So we're going to say while tries is less than or equal to 3. Then we prompt the user. Name the computer that played on Jeopardy. Response equals console read line. Now we have an if statement. If response equals answer, console write line, that's right. And right here we're going to have a break because we don't need to continue. This is a situation where a break is perfectly acceptable because we don't need to keep trying. The user got the answer correctly, and we're ready to stop the program. However, if they didn't get it right, and the number of tries is less than 3, then we want to prompt the user, sorry, try again. And then to close off the loop, we need to increment tries by 1 so that our loop will eventually stop. Then at the end of the program, we check to see if the user never answered the question correctly, and if so, we say, sorry, the answer is Watson. And that's the whole program. So from the previous program that we wrote that did this, notice how we've saved quite a bit of space, made the program much easier to read. We don't need a lot of nested if statements. We just need one if-else if inside the loop and then another one at the end. But this program is so much easier to read and a little bit shorter also. So let's test it a little bit. So let's get it right the first time and get that out of the way. So there we go. So now let's try it again. Well, let's say Deep Blue. That's the chess playing program. Sorry, try again. Let's try ENIAC. Sorry, try again. Well, let's just say Bob. Sorry, the answer is Watson. Let's get it right on the second try this time. So we'll say Deep Blue. Sorry, try again. And we'll say Watson. That's right. So that's a way to write the question answer program that used nested if statements using a loop. Now we can also write this program using a for loop. So let me show you how to do that real quick. All we need is to replace the while loop. So we'll comment that code out. We'll drop down here right below it and we'll say for int tries equals 1, tries less than equal to 3. I'll tell you what, let's do it less than 4. Doesn't really matter though. Plus plus tries, console write. Oh, I see. We're getting the error because tries has already been declared, so I just need to comment it out up there. That fixes that problem. Console write, name the computer that played on Jeopardy. Response equals console read line. And we can actually copy this code right here as is. We'll have to get the comments out, but that's easier than typing it back in again right here. All we got to do is come through here and remove the comments. Close the for loop right here. And everything looks in place. Let's give it a shot. Let's get all 3 attempts wrong. Deep Blue, ENIAC, Bob. There we go. Let's get it right in 2. Deep Blue, Watson. And that's probably good enough to test. So we have 2 different ways to write this program using either a while loop or a for loop. And we also demonstrate in both loops how the break statement can be used to make your program a little bit easier to write, and it's certainly understandable. One of the critiques of the break statement is that it makes your programs harder to understand. But I don't see any problem with following this program using the break statement, and it's definitely the easiest way to write this code. So that's about it for this exercise. Let's move to exercise 2 of this chapter, where we rewrite the calculator program that we wrote in the last chapter using a loop. For this exercise, we're going to take the calculator program we wrote in the last chapter and put it inside a while loop so that we can run the program as long as we want to run it. So let's get started. First thing we need are 2 operand variables, operand 1 and operand 2. Then we need a variable to store if we want to continue. We'll call it more and set it to y. And then finally we need a variable for the operator, and with that we're ready to start. So we'll say while more is equal to y, console write, enter operand 1, operand 1 equals convert to double, console read line, then prompt for operand 2. Now we're ready to enter the operator, so we prompt the user first. And that's a convert to char. Now we have a series of if statements. Let me scroll up a little bit here. If op equals plus, console write line, operand 1 plus operand 2. Else if op equals minus, console write line, operand 1 minus operand 2. Else if op equals multiplication, the asterisk, console write line, operand 1 times operand 2, else if op equals divide. Now here's where we prompt the user. We'll say another calculation. It's always good to let them know what you're expecting for input, so put a little yes no prompt there. And then more equals convert to char console read line. And then at the bottom, thank you for using the calculator, just to be friendly to our users. All right, so let's run the program. So the first time in, we're not prompted if we want to continue, since this is our first time in, so we'll just hit a couple of numbers here and do a plus. I'm not worried so much about the operation of the calculator. Another calculation, yes. 23, 232, multiply. Yes, let's do one more. 34, 2.2, divide. No. So that's how it works. Now again, I'm not trying to make any sort of claims of this being a very great calculator program. We are going to keep building on this throughout the course, but it's a good example of working with if statements. It's a good example of working with while loop. Gives us a chance to act like a regular calculator, which constantly is coming back to its prompt to let the user enter something else. But it's not perfect. That's okay. That wraps up this chapter on looping. And now we're ready to move to another major chapter in this course on creating our own methods. Methods are the same thing as functions, if you're familiar with that term, but with methods, we're naming calculations that are longer than just 1 or 2 lines of code. For example, if we want to convert temperatures from Fahrenheit to Celsius, it makes sense to create a method for that conversion and name it so that rather than just have code throughout our program, we have named pieces of operations. Just like with the math functions. Absolute value, that's a named function. And that's what we're going to do in this next chapter, learn how to create our own methods.